Welcome to the Language of Mathematics and English Learners in MTSS webinar. The mission of the Pennsylvania Training and Technical Assistance Network, PATN, is to support the efforts and initiatives of the Bureau of Special Education and to build the capacity of local educational agencies to serve students who receive special education services. The Pennsylvania Department of Education's goal for each child is a commitment to least restrictive environment. PDE's goal for each child is to ensure individualized educational program teams begin with the general education setting with the use of supplementary aids and services before considering a more restrictive environment. The participant outcomes for this webinar are the following. Participants will connect research on effective teaching strategies to support English learners' language development in the content area of mathematics. Participants will identify and apply culturally responsive strategies to facilitate academic language development in the area of mathematics. Before we address the role of language in the teaching of mathematics, we must first place the topic in its greater context. The Pennsylvania multi-tiered system of supports focuses both on academic systems and behavior systems. MTSS is an instructional framework that includes universal screening of all students, multiple tiers of instruction and support services, and an integrated data collection and assessment system to inform decisions at each tier of instruction. MTSS is intended to help all students meet with continuous academic and behavioral success by providing tiered services and supports to catch students before they fail in a recursive and systematic problem-solving process. In Tier 1, standards-aligned instruction and school-wide foundational interventions are provided to all students, including students who are English learners in the general education core curriculum. Tier 1 also is used to designate students who are making expected grade level progress, the benchmark students, in the standards-aligned system and who demonstrate social competence. English language development, or ELD instruction, is provided in Tier 1 for English learners. ELD in Pennsylvania is core content. The focus on language use in planned Tier 1 standards-aligned instruction in the content area and ELD classrooms. In Tier 2, strategic interventions are provided for some students. Academic instruction and behavioral strategies, methodologies, and practices are designed for some students not making expected progress in the standards-aligned system and are at risk for academic and behavioral failure. These students require additional academic and behavioral support to successfully engage in the learning process and succeed in the standards-aligned system. In some instances, English learners may need additional supports provided in Tier 2. Please remember that not all English learners will need Tier 2 interventions. The student's ecology and English language proficiency levels must be considered in the decision-making process. In Tier 3, intensive interventions are provided for a few students. Academic instruction and behavioral strategies, methodologies, and practices are designed for a few students significantly below established grade level benchmarks in the standards-aligned system or who demonstrate significant difficulties with behavioral and social competence. For English learners, again, it is important to remember to take into consideration the ecology of these students. The Pennsylvania Common Core Standards for Mathematics detail 4 standard areas described on this slide. Assessment in mathematics should reflect the competencies that lie within each of these 4 Pennsylvania Common Core standard areas. Practitioners are strongly encouraged to use a broad continuum of reliable and valid measures or data sources that have been normed with English learners. How many of you are familiar with the Scarborough Rope of Literacy? The mathematics proficiency rope is a similar parallel. As illustrated in this figure, the development of mathematical proficiency is contingent upon the interaction and interdependency of multiple strands. Mathematical proficiency is not a one-dimensional trait and cannot be achieved by focusing on just 1 or 2 of these strands. These strands are not independent. They represent different aspects of a complex whole. One piece of the rope is conceptual understanding. It refers to the integrated and functional grasp of mathematical ideas, which enables students to learn new ideas by connecting those ideas to what they already know. A few of the benefits of building conceptual understanding are that it supports retention and prevents common errors. Mathematics requires a conceptual understanding of a mathematical process in order to choose the correct operation or operations and perform the necessary steps to derive an answer. Some mathematical concepts can be very concrete, while others are abstract. To help English learners to succeed in the mathematics classroom, teachers need to connect previous knowledge and experience to new concepts that are being taught. An English learner may have learned the mathematical concept in a native language, but may not have the English language development to understand a discussion, read a textbook, or be able to express his or her own understanding. In this case, the English learner does not need to relearn the concept, but must learn new English words to talk about a previously learned concept. If the mathematical concept is new to the English learner, then the teacher must make the instruction more concrete, visual, collaborative, and hands-on. A more detailed description of effective instructional strategies for teaching mathematics can be found in Section 6 of the document, Adding It Up, by the NRC, cited on this slide. Procedural fluency refers to knowledge of procedures, knowledge of when and how to use them appropriately, and skill in performing them flexibly, accurately, and efficiently. In the domain of number, procedural fluency is especially needed to support conceptual understanding of place value and the meanings of rational numbers. It also supports the analysis of similarities and differences between methods for finding certain sums, differences, products, or quotients, as well as methods that use calculators, computers, or manipulative materials such as blocks, counters, or beads. English learners will need linguistic supports in expressing their procedural fluency. The third rope is strategic competence. It is the ability to formulate, represent, and solve mathematical problems. Strategic competence refers to the ability to formulate mathematical problems, represent them, and solve them. This strand is similar to what has been called problem solving and problem formulation in the literature of mathematics, education, and cognitive science, and mathematical problem solving in particular has been studied extensively. Later in this webinar, we will address ways we can support English learners in problem solving and suggest some linguistic and cultural scaffolds. Adaptive reasoning refers to the capacity to think logically about the relationships among concepts and situations. Such reasoning is correct and valid, stems from careful consideration of alternatives, and includes knowledge of how to justify the conclusions. In mathematics, adaptive reasoning is the glue that holds everything together, the lodestar that guides learning. One uses it to navigate through the many facts, procedures, concepts, and solution methods, and to see that they all fit together in some way, that they make sense. In the final rope, we address productive disposition. It refers to the tendency to see sense in mathematics, to perceive it as both useful and worthwhile, to believe that steady effort in learning mathematics pays off, and to see oneself as an effective learner and doer of mathematics. If students are to develop conceptual understanding, procedural fluency, strategic competence, and adaptive reasoning abilities, they must believe that mathematics is understandable, not arbitrary, that with diligent effort it can be learned and used, and that they are capable of figuring it out. Developing a productive disposition requires frequent opportunities to make sense of mathematics, to recognize the benefits of perseverance, and to experience the rewards of sense-making in mathematics. Therefore, instruction should emphasize inquiry, relevance, and a multi-layered vision of proficiency as indicated by the rope on this slide. The following Common Core standards of mathematical practice are reflected in the mathematics proficiency rope that we just examined in the previous slide. Mathematics teachers must help all students, including English learners, make sense of problems and persevere in solving them. Make sense of quantities and their relationships in problem situations. Help them understand and use stated assumptions, definitions, and previously established results and construct arguments. Help them apply the mathematics they know to solve problems arising in everyday life, society, and the workplace. Mathematically proficient students consider the available tools when solving mathematical problems. These tools might include pencil and paper, concrete models, a ruler, a protractor, a calculator, a spreadsheet, a computer algebra system, a statistical package, or dynamic geometry software. Proficient students are sufficiently familiar with tools appropriate for their grade or course to make sound decisions about when each of these tools might be helpful, recognizing both the insight to be gained and their limitations. Mathematically proficient students try to communicate precisely to others, look closely to discern a pattern or structure, and finally, mathematically proficient students notice if calculations are repeated and look both for general methods and for shortcuts. These new disciplinary practices in mathematics remind us that learning math is much more than memorizing formulas or procedures or taxonomies. Learning math means learning how to think in particular ways, how to argue from evidence, and create models that explain our emergent understanding. When we help our students engage together in these practices by facilitating their discussion of complex ideas, we provide multiple opportunities for all our students to become more effective users of English. Now that we have addressed what is mathematics proficiency in the mathematics standards of practice, we will turn our attention to the language of mathematics. What language must students appropriate in order to think, speak, and write like a mathematician? When teaching ELs how to approach word problems, it's important to become aware of confusing aspects or obstacles that must be addressed in an effort to support our students as they attempt to solve these word problems. They may lack background knowledge. Notice the importance in providing our students with the background knowledge they'll need in an effort to understand the problem. There will need to be an explicit discussion of terms such as sea level, how far apart, will be crucial to solving this math word problem. In number 2, the same pronoun is used to refer to different subjects. Knowledge of pronouns and its reference is crucial in solving this math problem. Three, unclear directions. In many cases, unclear directions will derail English learners. Making sure that students are clear about the directions within the word problem is essential. Many times the directions are complex and multi-tiered. Simplifying the directions or amplifying in other cases will ensure that the student is able to solve the problem with those additional supports. In math problems, often there is the use of several small words. Be sure to explicitly teach and provide ample practices of those commonly known words, composed of several small ones, such as is given by, that take on specific meaning related to mathematics, sum of, total, etc. Shifting subject reference, in this case relating to the grandmother and to the account, might also be confusing for ELS. Clarifying those subject reference would be helpful for the English learner. To work on the language of specific disciplines, we need to realize the complexity of mathematical language for both native English speakers and English learners. It is not only specialized vocabulary involving new words, but also new meanings for familiar words. It's also extended discourse that includes syntax and organization, the mathematics register and discourse practices. In a nutshell, you don't talk about math the same way you talk about social studies. Research also describes how mathematical communication is more than vocabulary. While vocabulary is necessary, it is not sufficient. Learning to communicate mathematically is not merely or primarily a matter of learning vocabulary. The language of math is not universal. We use the phrase the language of mathematics not to mean a list of vocabulary or technical words with precise meanings, but the communicative competence necessary and sufficient for competent participation in mathematical discourse practices. Mathematics instruction for ELS starts by knowing your students. Mathematics instruction should treat language as a resource in English language learners and not a deficit. Address much more than vocabulary and support ELS participation in mathematical discussions as they learn English. Mathematics instruction has to draw on multiple resources available in classrooms to provide supports, such as manipulatives, drawings, graphs, and gestures, as well as the use of home languages and experiences outside of school. Research on language that is specific to mathematics instruction for ELS provides several guidelines for instructional practices for teaching ELS mathematics. One of the goals of mathematics instruction for ELS should be to support all students regardless of their proficiency in English in participating in discussions that focus on important mathematical concepts and reasoning rather than on pronunciation, vocabulary, or low-level linguistic skills. By learning to recognize how ELS express their mathematical ideas as they are learning English, in imperfect English, teachers can maintain a focus on mathematical reasoning as well as on language development. Word walls are used widely in mathematics, but are only effective if students have been introduced to those vocabulary words and have used them appropriately. Word walls should be provided as a reference. English learners not only deal with language barriers in the learning of mathematics, they also deal with cross-cultural challenges. Mental math. In many countries, mental math is the norm. Students perform mathematical procedures in their heads without showing the written steps taken to solve the problem. If they show the work, it may be shown in a unique way that is not the same as in the US. For long divisions, configurations and procedures may differ in various countries from what is the norm in the United States. In some countries, people tell time using a 24-hour clock rather than a 12. So in the afternoon, instead of being 2 o'clock, it would be 14 hours. In writing decimals, commas may be used instead of periods. Another factor is that in many cultures, math is not spirally taught. Math concepts may be taught at contrasting times in different countries. For example, algebra may be introduced in grade 3 in one country and grade 8 in another. Formulation of numerals may cause confusion for some students. Zeros in some cultures have a strike-through. Ones and sevens may be difficult for some students to recognize because of the way they are written here. Abbreviation of dates may vary. For example, in some countries, the day shows before the month followed by the year in the first example, and then as compared to the way we would write the date in that country. Mathematical concepts and systems are not necessarily universal. U.S. measurement system versus metric system. As we know, in more places in the world, countries of the world use the metric system compared to the U.S. empiric system. So they are at a disadvantage when we introduce the measuring system of the U.S. English learners will be most successful in instructional contexts that are language rich. Actively involving students in using language through oral and written discourse is essential. It requires both receptive and expressive understanding, employing all 4 domains of reading, listening, writing, and speaking, and requires students to use words in multiple ways over extended periods of time. As we conclude this section on the language of mathematics, please remember to offer students multiple opportunities to engage in mathematical discourse every day. In this section, we will focus our attention on what can mathematics teachers do. The first thing that mathematics teachers can do is use the WIDA performance definitions, as it provides us with definitions of what ELs know and are able to do at their level of English proficiency. It provides us the appropriate pace for instruction and assessment. Do collaborate with the ESL teachers who can provide additional linguistic supports. The WIDA performance definitions focuses on the receptive domains of listening and reading on this slide and the productive domains of speaking and writing on the following slide. The WIDA performance definitions focus on 3 dimensions of language that are represented in the different colors on this slide. Discourse dimension, sentence dimension, and word phrase dimension. English learners at a level 1 at the bottom of this slide will process the English language differently from an English learner at a level 3, for example. When teaching English learners, performance definitions should be used in creating objectives for the lesson at hand. It is important to note that the quantity and linguistic complexity will be dependent on the English language proficiency level of the student. Teachers must familiarize themselves with the WIDA performance indicators in order to understand what ELs know and are able to do at each level of English language proficiency and to linguistically differentiate their lessons accordingly. When teaching English learners, it's important to note again the quantity and linguistic complexity of speaking and writing, and that those will be dependent on the English language proficiency level of the student. For example, students at early proficiency levels of levels 1 and 2 will not necessarily be able to write complex sentences or to speak in complex sentences, but can certainly begin the writing process, for example, by sketching and potentially adding key vocabulary that has been explicitly taught. The use of pictorial representations with words or chunks of language is a good start for ELs at level 1. Teachers must familiarize themselves with the WIDA performance indicators in order to understand what ELs know and are able to do at each level of English language proficiency and provide the students with the linguistic supports necessary for the English learners to be successful in the mathematics classroom. As students move into level 3 developing or level 4 expanding, they can continue to develop their speaking and writing skills. Writing will be typically expanded sentences with emergent complexity and organized expression of ideas with emergent cohesion in sentences and paragraphs. As students progress towards level 5 bridging, varying language structures with increased grammatical accuracy and a broad range of sentence patterns can be expected. At that level, their writing and their speaking looks very similar to a native speaker. It is important to note that writing instruction should be taught simultaneously with reading, speaking, and listening skills for students at all proficiency levels. These 4 domains complement each other and help students to develop language proficiency as well as content knowledge. For English learners, the more they have the opportunity to interact with teachers and classmates, the more opportunities they have to acquire language. Their language acquisition will be accelerated when the teacher provides rich, comprehensible input and encourages higher levels of language production. There are a number of ways teachers can modify their language to anticipate and address the needs of English learners. Comprehensible checks. The teacher checks to see if the learner has understood. For example, the calculator must be put in your desk after use. The teacher follows that statement with the question, what will you do with the calculator? To ensure that the student understood the directions. Clarification requests. The teacher asks the learner to clarify a spoken communication by saying, can you say that again? Repetition or paraphrase. The teacher repeats or restates an utterance. For example, calculate the sine of a 25-degree angle. How can you use your calculator to find the sign? Or have another student restate what the teacher said would be another option. Nonverbal cues. The teacher supports utterances with visual cues such as gestures, written words, or pictures. And finally, in corrective feedback, the teacher judiciously rephrases the learner's speech with the correct forms within the flow of interactive conversation.
From looking at the area of the levels of English language development that our students bring to the table, we have to be very careful when we design lessons for our English learners. One way to look at a lesson design is by using this template. In the template, as you see, there is a section for preparation. When we talk about preparation, we expect the ESL teacher and the math teacher to have a conversation about not only the level of English language proficiency of the student, but also about their experiences with academic language and math through the grade level education that they might have had in their countries. It is important that that discussion happens, because that is going to be a way to really design lessons that are going to be successful with all students in your classroom, especially if you have ELs in your classroom again. So after that discussion, then, the standards to be addressed. As Francine has explained, our math standards really are very precise. They are precise with the concept development of math proficiency, but they are also precise in the way the students need to express their reasoning and explain some of their steps at acquiring or coming to an answer. So the standards are precise, the standards are important. So that discussion of what I am going to work with during math lesson is important. That is also part of the conversation. And definitely, what will be the vocabulary necessary for our students in your classroom, for all students to be able to manage in order to express their reasoning and also in order to acquire these new concepts that they are learning. Then comes after we look at vocabulary, which is not just a list of words, as we have said, but key understanding or key words to understand those concepts. Then we go to our lesson objectives. So what are we really going to, at the end of my lessons, have students know and be able to do? So the lesson objectives are important, because from the lesson objectives, then I have to look at formative assessment. How am I going to measure how my students are acquiring these concepts? All students. What supports and scaffolds will be necessary for my students to have during instruction that is going to provide me the results that I expect? Then comes the after I have my objectives and I know how many students are ELs in my classroom, then I have to start looking at scaffolds. And that part that says Model Performance Indicator, MPI, that is a very useful scaffold that we need to incorporate based on the level of English language proficiency. What we are going to see in the next slides is how an MPI really works to support learning of new concepts and also acquiring of a language that is going to be necessary for that student to solidify the new concept that they have learned. So an MPI is made up of a language function plus your content stem, what you are teaching, and then what supports are necessary for your students to achieve what you said they were going to achieve. Okay, so we will have illustrations of that. then your materials in your lesson plan, and then your procedures, and definitely at the end, your formative assessment. Okay, so this is just a template that you can use when you discuss with your ESL teacher how you're going to support your ELs in the classroom. Another feature that is important to understand and maybe have some discussion is that for many of our ELs, measurements are very different from the measurements that they have used in their countries. Most of them come from the metric system. And here, when you are giving problems on feet, miles, or, that will be a challenge. So be aware of that challenge. So you have to actually consider the fact that if you're giving word problems on measurements, somebody in contact with the ESL teacher, somebody would have explained this before. So it is not really something that you are going to explain again during class, because it has been somehow coordinated with your ESL teacher. Fractions can be also a challenge, because in many countries, really fractions are not stressed that much as are, decimals. Here also there is the decimal point that we use in some countries. It's not a point, it's a comma. So have that conversation with the ESL teacher about the students. That could be a challenge. Geometry, in some instances, if students come from Romance languages, the good news is that there are many words that are familiar because they come from the Latin root or Greek root. So that is important for students who speak Spanish, French, and other Romance languages. Algorithms, that's also something that is important. In many instances, not everybody follows the same procedures to get to an answer. So sometimes the algorithms are different in some countries. Use this as a way to actually have a teachable moment and ask students to show you how they can get to the same answer but using different processes. That could be something interesting for all your students. This is exactly what we were talking when we said about MPIs, the model performance definitions. This is how we provide our students with the scaffolds necessary to create tasks in our classroom that are totally aligned to what they know and they are able to do with language. They are still learning the same concept, but the way that we have worded the task is just to support that learning. Like if you look at the first level 1 scaffold or MPI, the first part of every single MPI is the function. That means what you do with language. Okay, like in the first one is orally identify. In this case, the lesson was about using data or organized data using different ways to represent data. Okay, so the point of the lesson really was to make students aware that there are different ways to organize data to represent something that you want to express with data. So if you have level 1 students, it says they're orally identified vocabulary. What vocabulary will be important? Well, I would like my students to know ahead of time or during my lesson if they can actually identify what is a graph, a line graph, a circle graph, what's a histogram, a bar graph. So if they have that vocabulary in place, that's a very good step for my level 1 to build on that vocabulary. So he will be using visual cues with a graphic organizer, maybe matching, the graph with the word, okay, with a bar graph. Where do you see a bar graph? Make a line to the word bar graph. So that kind of expectation at this point is because I want to solidify vocabulary at this point. For level 2, select a method and appropriate format to organize and display data with a partner. This is important. That's the support with a partner. So they are talking about which will be the best way to organize data, as opposed to a level 1 that the support actually is the graphic organizer, is the requirement to connect the word with the picture or the picture cue. Level 3, explain the reason, explain. Now we are requiring more language. Explain the reason to select a specific method to organize data, and so forth. For level 4, more language, offer an alternative method. And level 5, analyze data shown in multiple line graphs, circles, graphs, or histograms. So you see how you can actually create tasks that are aligned to the level of English language development that the children bring to the table. Are you actually using the same lesson? Yes, you are using your lesson on organizing data using different ways to organize it. This lesson is about fractions and solving problems with fractions. And as you see again, the very first part is the function. What students are required to actually do in the task. Level 1, identify keywords involving fractions or solving fraction problems using visual cues and manipulatives. Again, you identify what fractions or solving fraction problems, and then manipulatives, that is your support. And as you go higher in the levels of English language proficiency, the supports changed, and also the functions are more involved in regards to language. Okay? Recite or paraphrase, explain in short and some expanded sentences, describe a different approach, critique peer approaches. So you see how language becomes more, more proficient as we move in with the different levels. Where do I get these language functions that look so interesting? Well, you have to talk to your ESL teacher so you can look at the can-do descriptors. The can-do descriptors actually provide all of these language functions. It is important that you have that conversation. You have to go to the WIDA webpage, and at the end we have a whole bunch of resources that you will be able to take a look and see, some of the WIDA products. So this is a good way to just create tasks that are aligned to your students' level of English language proficiency. Oral strategies are very important for our ELs. Our English learners really have to be provided opportunities to actually develop that oral language, to be able to function within your classroom discussions, explanations of their reasoning, choices that they have to use different methods to reach to the same answer. These are just some strategies here that are going to help math teachers to connect verbally with their students. Remember, when you speak, try to really avoid using too much idiomatic expressions. And if you use them, give some explanations for that. Sometimes, if we use expressions such as like, are you pulling my leg, could be something that students can interpret literally. So that's what we mean by idioms or idiomatic expressions. Jargon is another, way to explain things when you are presenting. You need to model language a lot. So repetition is good for our ELs, and it's good also for your struggling learners. Try to really require from them to give you answers in complete sentences. That is so important. When you ask a question, require your students to give you an answer in a full sentence. That helps all students to really become better writers. Okay? In the case of our ELs, explain some homophones that we use, like the ones that we have there, plain and plain, rows and rows. And so some and some. That's important for them to hear you saying it and giving some explanation about they sound the same but they mean different. use some visual strategies. Yes, indeed, we need to be, every time you use a new word, a new term, write it on the blackboard. Give a little bit of analysis of the word. Ask them to think, what do you think this means? That helps students to really become more of word detectives. Connect some verbal or written and pictorial representations of the same word. Or maybe, you know, the word table. Who can think of the meaning of the word table? And students may actually look at table, you know, like the piece of furniture, but then you have to explain that this time table will have a different meaning in mathematics. So those are the kinds of things that are very enriching for ELs. And also be aware, like when you work with a ESL teacher, you know, may like to discuss some of these terms that will be a challenge for our ELs, and maybe, you know, decide if there's going to be an introduction of the words when they are during their ESL instruction. So it is important that these conversations actually will help us get to the place where we want them to get, which is achieving the standards that all children are expected to achieve. Vocabulary, as we were saying, is also very important. I think that having just words written in isolation sometimes could help some children, but not all children. Charts help also understand why this term means this and not that. It is important to point to some of our older students to some bilingual textbooks. Most math textbooks actually have their companions in Spanish when most of your students are Spanish speakers. When they are not, you know, there's always a good way to find ways to translate using technology. That is important because here we're working not only with language, but the most important component is concept attainment. And that needs to be, you know, considered when we work with English learners. You try to ask them to really, you know, create their own ways to write down terms that might be, they might not be that familiar with, drawing symbols. How is that in your first language? And sometimes, you know, that helps them make those connections. Something that is very challenging for your ELs is the patterns, the language patterns in the textbooks. Remember that we use a lot of expository text. That means there's a sequence, a problem, a solution, and sometimes your students might not be familiar with that kind of expository text. So it is important that you teach your children to navigate text, especially when you're using your mathematics textbooks. There is a way to interpret when we read some mathematics definitions, for example. You need to do a lot of that introduction with your ELs or work with the ESL teacher to work with that text beforehand. Okay, so students will not focus on the complexity of the text, but they will focus more on the concept that you are introducing or the mathematical concepts that you are going to work with that week. It is important, again, that you navigate with them, like the titles, the headings, the charts, the subheadings, the conclusions, and pointing at important words that give you contextual clues to sample. For example, if the word operation, they think about maybe operation in a different context. Like a surgical procedure. Well, in this case, operation means something different. Okay, so that is important for you as a math teacher to understand, that the conversations that you have with your ESL teacher is going to facilitate, is going to be used as a scaffold. Using first language as a scaffold is also important, and it will not deter from your students learning English. Okay, so if there is a point where you need to assign students to go into their first language to understand a concept, that is fine. That's okay. The important part is that they are learning those concepts. We have, Francine, I think, explained to you the importance of oral language and talking in your classrooms. Here we have we call it the Math Academic Conversation Placemat. You have a place where you can go, there's a website that you can go, and it's on the bottom of this slide. My advice to you, if you really want to read this well, is to go and copy this chart from Jeff Zweers, and you have there the address where you can find it. But why do we have this here? For us as educators, it is important that we actually facilitate discussions and explanations in our classroom, providing students with scaffolds. And one piece that you see in this is that if we are going to talk about a problem and we're going to try to solve it, so what would be important for my students to have as a response starter that is going to help them explain something or is going to help them to get information about how to go about something. So here you have excellent response starters, like in the first component, jointly analyze a problem. Then use multiple approaches and representations. Yes, we do that a lot in math, right? Different ways to represent or approaches to solve the problem. Provide your students, especially ELs, with some response starters. Maybe we can use, another way to show this is, in math symbols we could write, that's important. Have them written on a chart, have them written, or available for them as a visual, so they can actually, use the right way to reason or to explain their reasoning. The same way to explain and support reasoning, as I am saying, you have their sentence starters for students to use. And the more they use it, then it becomes part of their vocabulary. That's the important part of having these scaffolds around in your room, so students will actually just turn around and start looking for them, or if you select 2 or 3 that you use constantly, then you can use others. And then eventually that will become part of their repertoire. This is a very good tool, and it's good for all grades, actually. The next slide comes also from another resource, and you have the resource at www.sentenceframes.com. We really looked at these areas because we don't see this a lot in math classes. And actually, this is going to be great help for all your students, because not all your students have the vocabulary necessary to express themselves. They sometimes need that extra prep, especially your ELs, okay, at different levels of English language proficiency. So this is a good resource for you to investigate with your ESL teacher and then maybe come up with some that you would like to try. And the good thing is that it's organized by grade level, and it's really by topic also. Okay, so this is another one, likeness and difference, and I love the way they prompt students to actually use this language and looking at the rectangles and make those comparisons. This is important vocabulary they need to practice. All students, but more so your ELs. And if you like, you would like to see more, especially with the MPIs that I show you, the function, the content, and the support, you can always go to PDSAS. There is a section that shows the ELL overlays for mathematics, and you will find excellent ideas there also. So it is important to see what is available for you to improve or to even, spice up your instruction in math. Another piece of information that we found as we were researching this topic, understanding language from Stanford University really provides with very, very good resources. This one in particular that we are citing here is really helping students to understand mathematics problems or math problems. So it gives step by step what strategies they need to be doing, especially ELs, in order to facilitate their comprehension of text and also the design of their strategies to solve the problems. So this is, another way to really scaffold what you really need to do with your students. The good thing is that it has really different steps that you can actually, look at them and follow them with your whole class, or maybe work with the ESL teacher to strengthen the possibilities of your ELs to understand and work with different problems. We also have other resources through WIDA. If you go to our WIDA webpage and type just sensory supports by content areas, you're going to get this chart, which shows, some of the supports related to the language of math. And this is important because you have to understand that there are very specific supports that you can use with your ELs in order to make your instruction more equitable. The same way for interactive supports. So interactive supports, sensory supports, graphic supports, or interactive supports are important because sometimes we look at just maybe graphic supports, but also having children working with a partner or in triads or with a small group is important because in that way language is also developed that way. It is also important when we say strategic use of the native language of the students. That's crucial, especially when you have students who are newcomers, students who are new to the country, and they have had strong mathematical instruction in their native language. So you want to bridge that because the concepts are there. They just need to, learn enough English to express those concepts. Cooperative group structures are important. There's also software programs. Talk to your technology people. There's different ways to support your ELs with interactive supports. And our good old graphic organizers, I don't know what did we do before them, but they are important. They are part now of the way that we explain different ways to support our students. And I think that we know that how important it is to look at the language of mathematics specifically for these kinds of graphic organizers. WIDA also and PDE have many resources that you can tap onto. As I explained before, the can-do descriptors, we already showed you the performance definitions, the can-do key uses, ELD standard number 3, which definitely addresses math as part of our 5 standards. And please visit the PDSAS overlays that will give you very good ideas. Progress monitoring. Progress monitoring is part of the framework that Francine described in MTSS. If we look at the heart of MTSS, really is equal access. And when we look at how can we provide equal access for all of our students in a multi-tier systems of support, we also need to look at equity, and we need to look at how are we collecting data in order to make decisions. One of the pieces that is also very important in MTSS, since it's a problem-solving approach, is, so what do I use to actually collect data so I am making the right decisions for my students? And one way to look at it is what research tells you that effective progress monitoring looks like. If we look at this chart, and beginning on the left, measures the behavior outlined in the goal. So when I select my objectives, am I really measuring how well my students are achieving those objectives? Uses an equivalent measure each time. Yes, you have to be collecting data over time using the same methodology, or maybe using, the same approach. Provides regular and frequent data collection. Yeah, when do I do it? Do I do it twice a week? Do I do it once a week? Every 2 weeks? That's important that you have some sort of a schedule to collect data. It's easy to implement. Am I using, formative assessment that has a variety of ways, but it's easy to implement. And it's not taking really a lot of time from instruction, which is the next one, and allows for analysis of performance over time. And that is definitely, what research tells us that effective progress monitoring is all about. And if we add to this the idea that we are dealing with students who are second language learners, then we have to also look at how am I implementing this process, right? So is there collaboration in designing lessons based on the levels of English language proficiency of my students? Remember, culturally responsive instruction is including all students in your instruction. So that is the first step. Do I know what level of English language proficiency my students have during my math instruction? Am I using formative assessment that is aligned to the levels of English language proficiency? Am I really engaged in activities such as the ones that we described before with the MPIs to develop language and mathematics concepts? And 4, students respond to formative assessments plan in step 1. Data is collected and teacher provides feedback. That's also important. How am I providing feedback to my ELs and to all of my students? And then teams use data on language development and math concepts attainment to improve instruction. What are the conversations that we have in regards to data that is collected in math, and it's discussed with ESL teachers? The same way we look at developing strong instructional strategies with scaffolds, we also need to now look at our assessment. Okay, so why do we need to look at the way that we are assessing? Because many times, and this is, common practice in some districts that I have visited, in many instances, the math teachers have their assessments ready for all their students, and their assessments actually need some accommodations, and therefore they are giving the assessments to the ESL teacher so she can implement, she can have the students responding to the questions of the written assessment, and they are supposed to be, making all of the adaptations and accommodations. Well, that in itself does not tell me that the evaluation or the assessment has been developed with all students in mind. Okay, so when you look at your assessment, you have to actually look at all of these areas. If you want to go deeper into how to do this, At the bottom of this slide, there is this is a PDF you can download. It's Evaluation Tool Assessment Instrument Quality. Okay, so how am I going to measure the quality of my assessment? This PDF gives you excellent pointers in how to look at your assessment. It is important to consider the following. Is your assessment actually assessing the objectives of your lesson? Are you able to provide a balance between, procedural fluency and demonstration of understanding? The question phrasing, is it precise? Is it, clear? The questions are clear, considering the fact that you have ELs in your classroom. Are you using different formats? Maybe at some point you are asking for maybe graphs or maybe pictures or maybe different ways to represent your, the concept attained. Are your directions clear? Do you have visual presentations? Are you allotting enough time for your ELs to process this new language to be able to answer those questions? Are these formats really promoting student responsibility for learning? So these are very important issues that are addressed in that PDF and that you should be thinking about in developing your assessment. Once the assessment is implementing, let's go now to the next step, providing feedback, providing students with a way to actually look at their errors and, look at where the mistake is so they do not do it again, right? So how do we work with our students to do some error analysis? And this is so important for our ELs. This is a very good way to have conversations because sometimes the errors could be operational or procedural or just that word that they couldn't understand, therefore they couldn't answer the problem well. So that's important to have some time for error analysis and some time to connect with your students to look at some of the errors that they may have had. They could have had fact errors. Maybe they didn't look at the numbers right. Operation errors. Maybe they didn't look at the way the steps in answering the problem. Or maybe they added instead of subtracting. Maybe the algorithm was done in a different way. Okay, so procedural error, placement errors, incorrect steps, missing steps, they skip a step. Okay, so once I decide to actually look at my students' papers, looking at where the mistakes were or the errors were, then it is important to also look at if we know that we're going to have word problems or if we are going to actually provide some statements for students to react or answer. Remember, reading is a challenge for some of our students. Not only ELs, but also students that have some reading gaps or deficiencies. So it is important to look at whether it was a reading error or a comprehension error. Maybe there's a word that means, has multiple meanings and the student misinterpret the word. Then transformation errors. Maybe the student really does not know what is asked in this problem. They couldn't read the question and they start to answer a question that is not there. The same with procedural errors or encoding errors that maybe, they couldn't actually write the solution to the problem. That's when students really misinterpret the question. In many instances, if you focus your students in looking at what is the question in the problem, they will be able to actually proceed in a different manner. And then have an interview with your students. Sit down with your students and start asking, looking at their papers and circling their errors. Let's, create a procedure for them to be able to answer questions better. Sometimes we need to actually teach students how to read the question, ask them to actually explain what the question was asking to do, okay? And then ask them to, how would you plan to find this answer? And then tell me or show me, how did you get to the answer? And then tell me what your answer was. And even answering the question using a full sentence is going to help them actually look at this whole process in a different manner. I have seen teachers actually doing this with small groups of students, or sometimes, having students one-on-one, but mostly with small groups of students, and even empowering students to do this, in pairs. So, read the question, explain what the question. So that is something that you could actually implement very easily, and in a collaboration maybe with your ESL teacher if you have students who are at lower levels of English language proficiency. Now we're going to move to some other resources that through our research we have come up with. As you know, this is something that maybe you can actually share with counselors. We know that according to research, students in order to graduate actually need to have those 4 years of math at the high school level. So this is a tool that was developed by Real West, and it's designed for teachers and school counselors that are preparing their students actually to graduate and meeting the standards required for students to graduate. So the important part here is that planning is important. And in many instances, especially with ELs who are very new to the system, these kinds of sit-down planning, explaining needs to happen with them. They sometimes start 9th grade, and if some explanations and some planning is not happening, then by the time that it's time for them to graduate, then all of a sudden they are missing some credits. They don't have enough credits. So this is to avoid really that kind of lack of planning that sometimes our ELs have. Very important tool to share with your counselors. So we finish with the section of what can math teachers do. So here we are starting with a section where we address what ESL teachers need to do in order to support math instruction. Number one, we all are familiar with our standards. We know that these standards really address also academic language development. And that is the charge not only of the ESL teacher, but of the content teachers, right? But looking at our side, ESL, why is it important that we look at language from the perspective of form, use, and content? This is so important because that goes, directly into the development of academic language. Why is it important to look at lexicon, at semantics, not just vocabulary, like sometimes people think of a, list of words that will be important for the students to learn, but lexicon, expressive vocabulary, ways that I can actually explain something, use it, to write a response to a problem. That's the important part when we look at the content and how we can actually help our students really achieve that language of math that is going to help them actually achieve those standards that we want them to achieve at grade level. So when we teach language during ESL instruction, yes, we are focusing on form and use, but let's not forget that semantics, vocabulary, lexicon is also very important, that we need to look at specific language that is required, for example, in this case, for math. And that is why we all need to be talking to our, math colleagues to actually infuse in our instruction some of the most specific lexicon that is necessary for our students to be successful during math instruction. This mathematical knowledge that we know that happens in the classroom deals with conceptual knowledge, procedural knowledge, and linguistic knowledge. So we have to elaborate more during ESL on that linguistic knowledge. When we look at linguistic knowledge, really we have to consider that, yes, indeed, mathematics can be particularly a challenge for our ELs because of all of these components that are linguistic knowledge, conceptual knowledge, and procedural knowledge. For example, we know that there are some challenges when we talk about addition. Okay, addition also implies the word add, plus, and, combine, sum, total of, more than, increased by, greater than. If we really are looking at the lexicon that involves, what is the concept of addition, the same way with subtraction. If we think of subtraction, what does subtraction also entitles? Well, the word subtract, minus, less than, fewer than, decreased by, difference, lower, take away from, and shorter, and so forth. So that's the language that we need to be cognizant. That is the linguistic challenge that we have in developing this language of math. Okay? Not only it is important to consider the lexicon, but also the grammatical patterns and the rules. They also need to learn unique meanings that some English words have in mathematical context. In order to understand mathematics, students must learn many content-specific lexicon like quotient, equivalent, and so forth, and also know the meaning of many complex phrases, like the least common denominator, or multiple, or greatest common factor. So those are the kinds of phrases that need to be, brought up in discussions or in different texts that we have from our math books. Bring that vocabulary into our EL instruction, okay? We also need to know that there are certain words that have multiple meanings, okay? Like bring down in math means different. A tree in math means different. Face, plane, cone, net, positive, negative. Consider that as a way to actually look for multiple meanings, okay? Prepositions are always a challenge for all ELs. I have a hard time with prepositions, and I am, I consider myself very bilingual. But sometimes, the way that you use prepositions in math is different than it is when you use it in a narrative in literature, okay? So those are the variations that we need to understand. Suffixes and prefixes, tri, bi, poly. So those are the kinds of conversations and instructional moments that we need to have during ESL instruction. This is really, this mathematical sentence construction, like if x equals 5, then, so those are mathematical sentences. And how do I bring that into my instruction? Because they will be facing those sentences when they go back into their classrooms. Passive voice, 20 is divided by 5. That is hard for ELs. So how do you address that? How do you really start looking at these patterns in your ESL instruction? All right? And again, mathematical operations are associated with many different words. Look at those math textbooks. When I was an ESL teacher, I used to have a copy of their math textbook, and I sometimes would pull one problem and we will work it out with the students, looking at very specific questions, specific patterns that will help me really explain my reasoning. And let's not forget that WIDA has always given us some pointers. For example, there's an area where WIDA looks at the academic language of math. And so when they look at the linguistic complexity at the discourse level, that's, the examples of that is you need to include word problems, explanations, tables, graphs, all kinds of different ways to express oral and written discourse in math. When you are talking about language forms and conventions, that is at the sentence level, you need to look for logical connectors. Consequently, if, then, in conclusion, those are the kinds of, or as the last result, those are the kinds of connectors that you need to introduce. We do a lot of comparisons in math, okay? Greater than, lesser than. Passive voice, remember, 20 divided by 5. Vocabulary usage, general terms associated with multiple contents, combine, describe, therefore. Specific terms associated with the content area. Least common denominator, less than, okay? Technical terms associated with specific content area, ratio, mode, integrals, theorems, all of that is part of that technical terms associated with math. So how do I incorporate this into my ESL instruction is important. And that the only way I will be able to be very targeted and, teach with a purpose is by working with a math teacher, is by knowing exactly where in this textbook I can pull from this math textbook to work with the specific terms that are going to be a challenge for my students. As we always say at the end of our webinars, we always have resources. So these are the resources that we have used. We recommend that also take a look at other states, our neighboring states that have gone deeper into the areas of teaching the language of math. We also have other resources there that you would like to really take a look. Always look at Coloring Colorado. That's a webpage that always, now it's addressing not only literacy development, but also math. We have the National Research Council, and PDE's, the SAS page has a lot of how to support your ELs developing vocabulary, or developing actually language for math and other content areas. This is more of what we have presented. Everything that you have seen in this webinar can be found in all of these different resources that we have. WIDA is the strongest resource that we can use, so please visit that webpage. We are a state part of the consortium, the WIDA consortium, so we have the right to really use their materials. If you have questions or comments regarding this presentation, please write to Dr. Victor Rodriguez Diaz. His address is there, and thank you very much for your attention, and expect to find other webinars relating to math, social studies, and science that will be presented in the near future.